Okay. Fine. So let me share my screen. Just a minute. Okay. Okay, I hope that you are seeing my screen. Okay. And in the last class, we finished our class discussing about what is a paleosol, and I present to you some definitions, some old definitions like this one, but the first one definition, just a minute, I think, okay, the first definition, the first time that a paleosol term was used by Putinov, and another definition and a modern definition about what are paleosols, especially according to the geologist. Okay, and now I ask you another question, that could we define types of paleosols? So do you think that we can classify paleosoils, or can we distinguish some of them between groups or orders or something like that? What do you think? Could we define or identify, okay, this is one type, one specific type of paleosols that are blah, blah, blah. We have another group of paleosols that are blah, blah, blah. And we have another group and blah, blah, blah. And we have like 4, 5, 6, 10 groups of paleosols. What do you think? And how can we define types of paleosols, if you think that we can distinguish them between groups?
In the text, you pass to read. I don't finish the text, but I understand about the types of paleosols. Don't have a order for paleosols, but the more common use is the soil taxonomy, incorporated the paleosols with the properties, okay, but don't have a order um, like older older orders, okay.
Mm-hmm. Mm-hmm.
Is the same group paleosols in the soil taxonomy, okay.
Okay. Mm-hmm. So you believe that you use the same system of soil classification to modern soils and to paleosols. We usually
Mhm.
use the same. It's right?
Okay, yes.
Okay, okay. Yes, it's what we usually do. Uh, Although some paleosols, they don't have a easy classification, because some properties change through time. So we will discuss about this about in the next class. But we can see some changes in color, in texture, in structure, and several other properties that doesn't help us to classify paleosoils in a specific way, using the same type, using the same criteria that we use to modern soils. So we usually do that, but it's not easy, as you said. But do you think that can we identify some types of paleosols? Can we thinking in this definitions, okay, that are soils formed in a past conditions, old and buried soils, and soils incorporated in the stratigraphic record. Thinking in these three definitions, could we identify types of paleosols? Do you think that could be possible?
I think yes.
Yes. And which types of paleosols? Remember, we don't have these questions.
Mm-hmm. Mm, mm, I don't remember in English, but I
Oh,
remember.
if you don't remember, you can say Portuguese and we can
Okay.
translate it. It's not a problem.
In Portuguese, we studied about the exumados. Só
Oh,
os
okay.
tipos.
Mhm.
Exumados, aí tem outro tipo, eu não tô lembrando agora.
Mhm.
Que são os que são. É como se fossem aqueles que são mais conservados. And others not conserved. Exumated.
Okay, exhumated.
Yes.
Okay,
Yes.
so Amanda, it's talking about some soils that was buried in the past, but today they are in the surface because erosion exhumated or exposed the soils that was buried in the past. Okay, so these soils are some paleosols. Okay, it's very interesting. This type, this group of paleosols. Okay, anyone has another group, another type of paleosol that could mention? Let me see. I'm sorry. Carolina or Miri, do you think that we have another type of or another group? Oh, sorry, here. Okay.
I think that we can have another group, maybe that emerged from volcanic activity. I don't know. So.
Mm-hmm. Uh-huh. No, specifically about that because the volcanic they can bury. So if you think that we have some soils that was buried and past, and we have some soils that are buried today. So we have two groups. Groups that are buried,
Yes, buried.
yes, and unburied or exposed. Okay, so
Yes.
we have two groups. Yes, and we have another one.
What,
No,
teacher?
and we
Can,
have another one type of paleosols. Let's see.
mm,
We can
one.
identify secondary soils, secondary paleosols. That are soils that was formed at least at two different stages of weathering. For example, I can draw here a soil. So we describe it and we identify a horizon and B1 horizon and B2 horizon and a C horizon. So, okay, we described then and we saw that A and B1 horizon, they have a specific characteristics, a particular characteristics, like we have 2+1 minerals. So we have elite, smectite, we have a high pH, we have a high cation exchange capacity, And we have a lot of properties that help us to understand that these horizons, they was formed in dry conditions.
Okay.
So we formed these horizons in a specific stage of weathering, that's very incipient weathering. So they formed in a specific climate conditions. And these ones, these other horizons, they have other properties, something like they have 1-to-1 minerals and oxides. So I identify gritite, hematite, kaolinite, halloysite. They have an acidic pH, a low pH. They have a low cationic exchange capacity. And I can understand that these horizons are formed in wet and tropical conditions. So we have two different stages of weathering, a specific climate condition that's different from another one. And how we have two different climate conditions, two different stages of weathering, we have a paleosol, because probably this specific condition, these wet conditions, probably are not the modern climate in the area. Probably the modern climate is this, but we don't need to know about that. At least two weathering stages, two different stages of weathering, we can identify as secondary soil, a secondary paleosol. So it's a kind of climate change paleosol. It's a soil that was formed in at least two different stages of weathering, and it's a type of paleosol. Okay? Everyone understand that? It's easy. So we understand that we have different kinds of climate change. Okay?
Okay, teacher.
Okay. We also can identify two stage soils, because they are soils that have different ages. So we can see some soils like this. Add another one, and in the field we'll describe an A horizon, and B1 horizon, and B2 horizon, and a C horizon. Okay, and I date the organic matter of these materials, or I date the formation of the iron oxides, or I date the formation of clay coatings. I date something in the soil, and something like that. I use carbon to date in this example, and I found here like 22,000 of years before present. So it's a very old horizon. It's a very old horizon formed in a different stage of time. It's a different age or period, or even an era. Okay, so I have a different time from this one. Here, if I date this horizon, I found something like 2,000 years before present. So it's a modern horizon formed in Holocene. And here we have a horizon formed in Pliocene. So have different stages of time. We can have the same weather. So weather here could be the same from here, but we have different stages of time. We have different
Teacher.
ages or, oh, Amanda?
Yes. Can be define. We can define all the paleosols have two-stage soils.
Could you repeat, please?
Okay. Oh, okay. We can define all the paleosols have two-stage soils.
Oh, no.
Okay.
Some of them can present uh, some very similar ages. Okay. For example, we can register some paleosols that all horizons and layers has less than 10,000 of years before present. So all of them are described in a Holocene time. So all of them has the same age. Okay, 10 and 2,000 of years are different. Okay, but we have the same age here. So
Okay.
we just have two-stage soils. When we have soils or horizons, horizons that have different ages, that have different periods or eras or times. Okay.
Okay.
And as I said, the climate could be the same or could be different. It's not a problem. Okay. We just think here in the time. So here we think in climate, and here we think in time. We have different soil formation factors that are the main property that we have to understand.
And different conditions.
Yes.
Okay, teacher. Okay.
And the last one are fossil soils, and these are the easiest. They are the buried soils. Oh, sorry. Buried soils. So if I have topography like that, if I have a hill and I have a terrace and I have a river here, I can identify a soil here, and I can identify some horizons, like this is an A horizon, a B horizon. So, okay, these horizons are formed in a surface, but erosion starts to remove material from here, and this material starts to run and was deposited here. And now I have several horizons here, like I can have another A, another B, and at least another C. And this horizon today is a AB horizon. It's a buried horizon. So I buried material, I buried a soil, and I have an overlying material that is also a soil, because it has horizons, it has pads, it has aggregates. So I buried a soil, an ancient soil that was formed in a surface. It could has a modern age. It could has, okay, I can date this horizon and see, okay, this soil was buried. I can date by OSL, and it could be buried at something like 2,000 of years before present, or 5,000 of years before present. And sometimes we can identify, okay, this soil was buried something like just only 20 years before present. So the age, it's not so high. It's very, very young. And climate, okay, the soil, the buried soil was formed in the same climate that we identify today. It's a wet climate that formed these horizons, and a wet climate also form all these horizons. We can identify the same properties, like we can identify the same minerals, we can identify the same pH, and the same conditions, physical and chemical conditions. They have the same, but I buried this soil, and as I buried it, some process start and some process stop it, and this create a condition to form a fossil soil, a paleosoil that was buried. Okay, so we have some paleosoils that were formed by climate. We have some soils that was formed by time, and we have some soils that was formed by relief plus parent material.
Teacher,
Yes, Amanda.
have a doubt. In this case, the OSL in the horizon AB is correct. Use the OSL in this case, or is better using horizon B, because I think the horizon AB can be more interference the with the relief in the material deposit material, and I think it's better prepare this same sample in the horizon B.
Okay.
You is okay or no?
No, no, Amanda, but let me explain why it's not okay, okay? So let us think again about the relief. Okay. And here we have, let me show here because it's easier, okay? Let me draw the horizon A and the horizon B and the horizon C, okay? And as we said, some material was eroded and was deposited here. So I have some sandy or clayic material. It's not a problem. And some process start to act here. And we have another horizons. And now we have a new A horizon. And we have a new B horizon. And here we need to change like 2AB, 2B, and 2C.
Okay.
And if I collect the OSA sample here, I will have the date, the age that the material here was buried. And if I collect a sample here, I can identify the age that this material was buried. And if I want to say, if I want to say which age all these horizons was buried, I should choose this horizon. Because in the past, this horizon was in a surface. And this horizon, he never been a surface. Never been. It always been buried, because the B horizon start to develop below the A horizon. So I should sample this horizon to
Mm-hmm.
know how much time this horizons, this soil was buried.
Okay. The
Do you agree
the
with me again?
yes, this case the better sample is the 2AB, horizon 2AB. Okay.
Yes, yes,
Okay.
yes. I choose this horizon to know how is the age that all this material was buried.
Mm-hmm.
When this material was eroded from here and was deposited here. I use this dating
Okay.
method.
Okay.
Okay?
Okay, teacher.
Okay. We will discuss about methods of soil dating in the next classes. So, if someone is not comfortable here to understand
Mm-hmm.
why we using OSL method, it's not a problem.
Mm-hmm.
You can just note that this method, this, they date the burial process.
Mm-hmm.
So I can know when a layer on a horizon or a sediment was eroded from a place and deposited in another place. So it's only what you need to know right now. Okay?
Okay. Okay. Teacher, can you close the audio, Millie, please?
Yes, just a
Okay.
moment.
Okay. Thanks.
Welcome. It's here. Oh,
Uh,
oh,
1 minute, teacher. The Johanna was participated more later this class, okay? But
okay, okay.
okay.
She, she's trying to enter in the class.
What, teacher?
Johanna is trying to be in a class.
No. They begin more later in this
Oh,
class.
okay, no
Okay.
problem, no problem.
Okay.
Let me just turn off your sound. So, okay, okay, and oh, it's here. Okay, no, it's not working. Okay, so we have these three kinds of, I'm sorry, we have these three types of paleosols. This one are formed by climate change, okay? These ones are formed by time, and these ones are formed by change of relief plus parent material. Of course, if I have a changing of climate, I could induce some burial formation, some burying, but I can bury some materials in the same climate. So if you have changing of climate conditions, we should define as this. If you have only a change of time, you should describe like this. And if you have some burial material, you should describe it like this. Okay? Are not these types are not official system of classification, but it's very useful to us to understand that we have three types of paleosols and that we can use then these terms, these words to describe these soils because helps a lot to understand which kind of process act in that landscape to create the paleosols. So I suggest you all the time to try to classify all paleosols that you see in the landscape in one of these types, these groups So helps a lot, because helps a lot to understand which process act in the landscape. Okay, so let's keep going. And we have some basic concepts that should be very, very segmented, that they should be very easy to access for you all, that it's how we define, how we identify some horizons and layers. Here, I will just use the soil taxonomy and world reference base for soil resources, because in Brazil, we have a soil classification system, but it's not a good soil classification system to paleosols, because we don't have some definitions that could be very interesting and useful to distinguish modern and paleosols. So we just use two. And because the Brazilian system of soil classification, it's very particular to Brazilians. So in general, non-Brazilians, they don't know, or they don't know how to use the Brazilian soil classification. Okay, system. So let's start. We have these organic horizons or layers. That is the O horizon or layer according to soil taxonomy, and according to WRB, the World Reference Base for Soil Resources, we have two options of organic horizons and organic layers. We have the H and the O horizon or layers. Okay, we'll describe that. All these ones are mineral horizons or layers, and these are the only organic horizons and layers that we have. Okay, and of course they have specific definitions that helps a lot to understand. You can see that we have a same concepts or same definitions from several of them, including this, but here we have little difference between them. Okay, here we have a different definition, and this horizon we can't understand, or we can't identify it in WRB definition. Okay, and this horizon, it's contained between it's contained into this horizon, but I will discuss about that. And this, it's the R layer. It's very common. The definition is easy, and we can identify the same concepts in the two soil classification systems that we will discuss. Okay. And so let's start with the organic horizons or layers. And as I said, we have in soil taxonomy only one organic horizon or layer. That's the O horizon. And this horizon or layer is formed by paludization and or littering. So this soil or this horizon, this horizon could be formed by water logging conditions. As you can see here, the water, and this water helps a lot to concentrate, to accumulate organic matter. So I have this process, paludization, that forms an organic material, organic horizons that was formed in water-logged conditions with low IH, low oxygen concentration, availability, okay? And we have reducing conditions that help, that favor concentration of organic matter. But we also have the littering process that is the concentration of organic matter in non-waterlogged conditions. So I can have a lot of oxygen, but I still have a lot of organic matter. And so I have also a organic horizon, an O horizon, and here a O horizon, or a O layer and a O layer, okay? In this case, we have some particular mechanisms, particular properties that helps to concentrate organic matter, like temperature. It's quite important to has low temperature, so the content of organic matter could be high, because in low temperature we decrease the microbiological activity, and we favor the concentration of organic matter. But we also can identify this kind of horizons in another environments, like high concentration of calcium or aluminum, or hydrophobic material that doesn't help the demineralization, the decomposition of the organic matter here. So we have the same organic horizon or layer, but we could identify different conditions, okay? So this horizon or this layer, it could be saturated by water, could be drained by man, or could never be saturated in this case. The O horizon, it's always identified in the surface, or it could be buried. So we can identify in the surface and subsurface in a soil profile, because what define organic horizon, it's the content of organic carbon and the color. I should have low values and low chroma, and a high content of organic carbon. Okay, at least 20% of organic carbon. It's a lot of organic carbon to identify organic horizon or organic layer in taxonomy.
Teacher, in the difference between the soil taxonomy and WRB, between the Sistema Brasileiro de Classificação do Solo, the quantity of organic carbon is high, because in the soil taxonomy and WRB is 20%. Okay?
Yes,
But no Sistema Brasileiro de Classificação do Solo, we use 8%, okay?
Yes.
The explication about this is about in Brazil have a more high climate, high temperatures is the explication, or no?
Maybe. Okay. Maybe it's not only explanation about why we use different values, we have different contents. Just to share a background with Millie, soil taxonomy and WRB, they use a same content. They use 20% of organic carbon to identify organic layer or organic horizon. In the Brazilian soil classification system, we call CBICS. In
Yes.
CBICS, the Brazilian one, we just use 8%.
8%.
So it's a very different value. We have a lower value. And
Yes.
why use that? First, it's because weather, as you said, we have higher temperatures, and higher temperatures induce decomposition of organic matter. So a lot of organic horizons and organic layers and organic soils in Brazil, they are not classified as organic layers or horizons or soils according to soil taxonomy or WRP. And it's the first point, it's why, because we have tropical and wet and sometimes dry climate that helps, that induce, that favor the composition of organic matter. So, okay, but we have a second point, and especially to WRB, that's very important, because in WRB, they have another group, soil group, that's the umbrasols. And these soils, they are soils that has a lot of organic matter. They have an umbric horizon that's a low pH, a high content of organic carbon, and a low cationic exchange capacity, and they have a lot of properties that remembers a lot histosol, but the organic carbon is lower. So they differentiate some soils that has a lot of organic carbon and some soils that has a lot but not so high as histosols. So they have another soil group that classify, that host some soils that has some high content of organic carbon, but not so high, like 8%, they will be classified as umbrasols. If you have at least 0.6% of organic carbon, you could be identified as an umbrasol. And they host a lot of organosolos in Brazilian soil classification system because the content of organic carbon. So the climate's not only answer, but it's the strongest answer that we can think. Okay, this is the strongest motive, that it's because of weather, but we also should understand that WRB, the WRB, they have another soil group to soils that has a high content, but it's not so high like histosols.
Okay, teacher. Thanks.
And, oh, welcome. And this is the soil taxonomy. We have just one horizon or layer which identifies unorganic material, an organic horizon. And in WRB, we have two different materials. We can identify the old horizon or old layer that was formed only by littering, that always formed in conditions that we don't have flooded, we don't have so much water, we don't have a reducing conditions. We have a lot of oxygen that helps the material to be decomposed, but some another property, some another condition in the landscape helps favor the accumulation of organic matter, like temperature. If you have low temperature, but you don't have a lot of water, we don't have a tidal water, we don't have stagnant conditions, you don't have gleic properties, you have only a lot of organic matter, you has a O horizon, you have a O horizon. And it could also be identified in the surface or can be buried. And you can identify a H horizon that's formed paludization, that's formed in saturated or drained conditions, drained by man, okay? And it also can be identified in the surface or in a buried horizon. So as you can see, the soil taxonomy, they mix this and WRB, they separate this in different horizons, okay? I like it very much, the WRB, because I think that's quite interesting to understand that we have different processes, we have different environments, and it's quite important, especially to us, if you start to understand or to describe a paleosol, that you describe the differences between a oxygen-rich area and a poor oxygen or a poor oxygen site. Okay?
Teacher, 1 minute. The difference between the latrine and the polarization is about the saturated.
Yes.
Okay.
Yes, it's the mechanism of accumulation of organic matter.
Okay.
Here, paludization, you accumulate organic matter because there's a lot of water and you have a low O2 pressure.
Mm-hmm.
And here we have a lot of oxygen, but you have a low water content, and you have another property that helps the accumulation of organic matter.
Okay.
Okay?
Okay. Okay, teacher.
Another horizon or layer is the L horizon, and the L horizon, it's a laminic and organic materials that was formed and deposited in a specific depth. So we can identify some diatomaces and some mineral material, some carbonates, and some salts that was accumulated in a specific layer. And these materials, this carbonate, they has specifically, it has a organic origin. So they was produced by organisms, and you can identify also accumulation of high content of organic matter. So as you can see here, we have a lot of content of a fabric material produced by algae and another organisms that was accumulated in the surface, but it also can be identified in the subsurface, or this material also can be buried. Okay, it's not a problem. So it could be organic or a mineral horizon, depending on the organic content. And these materials, oh, I'm sorry, it can't be an organic horizon, I'm sorry, just a mineral. But it has a lot of organic carbon content. So you can identify some high organic carbon content, but it should be below than 20%, okay? And you could identify a lot of organic materials there, but you also can identify a low content of organic carbon. It's not a problem. Could be high or could be low. It's not a problem. But if you have a high content of organic material, organic carbon, these organic materials should be in the same horizon, in the same depth, with laminic materials, like materials formed by organic activity, like calcium carbonate, like residues of algae, like diatomaceous, and another kinds of material, mineral materials. Okay? We have the A horizon. The A horizon, I think that's very easy to identify and to describe, is a mineral horizon that suffer melanization. The melanization is just the decrease of value and chroma of an horizon. So as we can see here, this horizon can also distinguish between this, okay, sorry, can see some horizons like this. These two horizons, and at least this one, are mineral horizons. So the content of organic carbon, it's low, it's not high, or at least it's lower than 20% of organic carbon, okay? But the material, it's dark. So you can see a dark horizon here. And why this horizon is dark? It's because the organic matter, it has been decomposed. So the decomposition of organic matter, it's getting the color of this horizon. It's getting it darker and darker and darker, okay? So if I identify a dark mineral horizon, I can identify a horizon. It's just something, a point that I have to highlight, that it always identify in the surface, but sometimes it will be buried. When a dark horizon is identified in a subsurface, so imagine that I have here a dark horizon, and I have here a horizon, and here I have another horizon, okay? And here we have a dark horizon. To understand if this is a horizon or a B horizon, it's very important to understand if this horizon was formed in a surface or it was formed in the subsurface. So if this material is dark because organic components, organic material have been decomposed in the past, and this get this dark color, okay, so it is a horizon. But if organic matter moves from upper horizons, from this horizon, and this get this horizon a dark color, so it's not a horizon. So the horizon, they should be formed in the surface. They should be formed in a surface. But you can identify it in a surface and sometimes in a subsurface. Sometimes it could be buried, but it always is formed in surface. It always is formed only by the composition of organic matter. Organic matter that illuviates, that moves, that changes across our horizons, don't form an horizon, form another thing, okay? And to soil taxonomy and WRB, some horizon that was formed by men that suffer anthropic disturbance, anthropic activity, it also is classified as a horizon. So if I found some soils like this one that has a lot of human activity, like you can see these shales and this human bone in our area, in a site that was formed by men. So you also identify this horizon as a horizon. Okay?
Okay, teacher.
Good, good. We have another one, an E-horizon. And an E-horizon, it's formed by eluviation of materials. These materials can be silicate clays, iron, aluminum oxides, organic matter, or a combination of all these materials. So as you can see here, very easily, you can see this irregular, transitional, irregular boundary between these horizons, okay? And here we have a white horizon, a material without color, and this white horizon, it's commonly sandy too, and this white and sandy horizon was formed by losing of materials that get color. So if I lose clay from this horizon to this other horizon, I'm losing color too. I'm losing a clay content too. So it starts to get sandy and white. So the E horizon is formed by eluviation, by losing of clay. This clay could be organic or inorganic clay, could be losing of organic material and could be losing of mineral materials. In this example, I have a huge A horizon here, and here I have an E horizon, okay? Here we have a B horizon. And a lot of people said that they know what is a B horizon, but sometimes we have some problems to definition of what is a B horizon. A lot of people just say that the B horizon is the horizon that has the strongest grade of the structure in a soil profile. But this is not true, because we can find a lot of B horizons that even has a grade, can be a horizon without structure, and we can't identify a pad or an aggregate. So it not have pad or aggregation, but it's a horizon and it is a B horizon. So what define a B horizon? It could be defined by some process that occurs in subsurface. So B horizon can be formed by eluviation, the migration of clay, and formation of clay coatings, the skin clay coatings, like can be a shiny surface of pads. This define a B horizon. So all B horizons can be identified by shiny pad surface. And of course, we don't have this shiny pad surface in all B horizons. But if you have a horizon with a shiny pad surface, you can identify that you have eluviation, clay eluviation, and so you have a B horizon, okay? You can also eluviate organic matter, and you can create a organic rich horizon in the in the subsurface, like this one. Here we can identify some horizons like this orange or yellow horizon. Let's identify, no, I'm sorry. We have the surface here, and we have another horizon here, and here, and here, and here, and all this thing, okay? This is a dark material, so it's a horizon. Here it's a yellow one. Let's call him a B horizon, but it's not a problem. Here we have a white and sandy horizon. Let's call it a E horizon. And here we have a dark material. Okay, JJ, so it's another A horizon? No. In this case, it is a B horizon, because in this case, this dark color comes from organic material that migrates from this horizon to this. So the concentration of organic material in this depth, this creates a B horizon. Because a B horizon is formed by elevation.
I never see a biosol or the B horizon buried in this case, but this picture is the good example.
Yes, but Amanda, in this case, the B horizon was not buried. It was formed in subsurface, okay?
Okay.
But you can identify some buried B horizons too, and buried spodic or podzols with a podic horizon in the subsurface. Okay, it's not a problem, but depends on the kind of or the type of paleosalt that you have. Okay. Good. And we can see a B horizon by glaciation too, by gleam properties. So you have anoxic conditions, reducing conditions. You also form a B horizon, like a BG horizon. It's not a problem, okay? And you can also identify a horizon, a B horizon, like here by clay elevation. It creates a texture that's very different from here to here. As you can see here, a white horizon seems that's very sandy too. And here we have a clayic and dark red horizon. Okay, so it's a B horizon too. And we can create a B horizon only by transformation of primary minerals like feldspars, like pyroxene, to secondary minerals like kyanite, goethite, hematite. This also form a B horizon. And pedalization. Pedalization is the process of formation of pads, or formation of aggregates. So if I have pads, if I have aggregates, I could have a B horizon. Okay, I could have a B horizon. What it's very important to understand, it's some B horizons are identified or can be seen on the surface, but all of them was formed in subsurface. Okay, all of them, because all process that creates a B horizon, it's process that act in a subsurface, not in a surface conditions. We also have the sea horizon or sea layer, that are horizons or layers that has a weak pedalization, a weak obliteration of the parent material, and they are not cemented. So we can identify a lot of materials that it's quite similar from the parent material. So we can identify a lot of bodies of rocks. We can find a lot of material that's formed by a deposition, like a deposition of alluvial beds or colluvial beds, okay? But we can identify several properties that's quite similar to the parent material. We can see some properties that remember us with which material was referred to form that soil, okay? And of course, they shouldn't be cemented. I can broke or I can catch this material and it's loosey, sometimes hard, but I can lose this material with my knife or my hand, okay? And they also can present pads, but we have usually a weak pedalization. We can't see a lot of pads, a strong grade in a sea horizon. That doesn't make sense. Okay. It's another horizon, another sea horizon. So I can see a lot of materials here, like pieces of rock, but this material, it's soft. I can just touch with my knife and it marks the material. So it's not a hard rock that's hard to break this material.
Teacher,
So,
in this case, your sea horizon or layer have a weak process, okay?
yes, in a sea horizon. Yes, we generally we don't see several processes in the sea horizon. Only pedalization and weak pedalization. Okay. In general, we see the weathering. So congruent and incongruent dissolution of minerals. Just this. Just this.
Okay.
Like this. In a dry forest, it's some soils, and you can see all this material that's loosey, it's not hard, so it's a sea horizon. Okay. And we can identify the R layer, that's the fresh rock. So we just can dig with materials that has a lot of power. So I only can excavate or I can dig a R layer with heavy power equipment. My knife, I can use my knife, I can use my hands, I can use a hammer and don't break this material because it's very hard, it's very resistant to weathering. So this is a R layer. It's quite different from the sea horizon or sea layer, because the sea horizon or sea layer, I can break the material very easily, and the R layer is very hard. It's very difficult to break this material. So it's the difference, okay? It's the difference between these two layers or horizon and the R layer. I can see E very easily. And we also can identify the W layer, the double U layer. They could be identified in the soil taxonomy as a same material, or it could be differentiated in two specific layers to WRB. Okay? To soil taxonomy, if you have a water layer, you have a double U layer. Okay, could be a liquid water or can be frozen water. So you can have ice or water in a liquid or solid stage. It's not a problem. You'll have only double layer. If you have the cemented, if you have the solid water, ice, you just use double UF to express that you have a solid water layer. Okay, and you just use double to this liquid layer. It's not a problem, but they are the same. And the word reference base for soil resource, we differentiate them into the liquid and the solid layers. If you have a solid water horizon or solid water layer, I'm sorry, so you have a I layer. If you have a liquid water layer, you have a double U layer. So they are different. Of course, in Africa and Brazil, we don't see these horizons, I'm sorry, these layers very easily, but we can identify in some regions around the world. So these pictures are in the Arctic and Antarctica. So we found these materials very easily there. But if I go to Europe and some places in Asia, some places in South America, we can identify ice and water in forming a specific layer. Okay.
Teacher, when I was working my dissertation, we studied with a histosol. In my histosol have a double layer.
Oh, good.
Is I think it's common in Brazil in this case in histosol.
Yes,
Because
yes,
it's
histosols.
not common. Yes.
Yes, because they have specific soil process formation. Yes,
Yes.
yes. Mhm. It's a good point. It's a good point. When you have flooding sites, flooding conditions,
Yes.
you can identify the W
Layer.
layer.
Mhm.
Okay. Mhm. Thank you. Oh, so now we finish the basic concepts for study of paleosols. Today, I think that's a good point to stop, because in the second class, we'll start to describe how the soil formation factors, they change the soil, and which properties we can identify according to the action, the interaction of each soil formation factors, and how these soil formation factors can change through time. So, okay, how the forming of paleosol, how a changing from a modern to a paleosol can be identified according to a specific soil formation. How a soil formation factor can express the genesis, the formation of that paleosol. So we describe specifically for organisms, parent material, climate, relief, all of these soil formation factors. Okay, I will share another reference, another material to you. So I ask that you read the material. If you have any doubt, if you have some question, just send me a mail. Has anyone has any question? It's okay.
It's okay, teacher.
It's okay.
Okay. Thank you, Midi. Oh, so thank you very much for this timing. I hope that you're doing well in this weekend, and I see you again in the next Wednesday.
Okay,
Okay.
thank you, teacher. Same to
Thank
you.
you, teacher.
Thank you.
Thank you.
See you.
Bye bye. See you.
Bye-bye, teacher.